Hi folks, welcome to this last video in the Pythagoras and trigonometry section. This one is on vectors, problems, and it's video number 186. Keywords I've got for you are the same as the other vectors video, but vector, magnitude, direction, scalar, key notation, arrow over the top, and underlined letter. So vector is something that has direction and magnitude. A vector quantity has direction and magnitude. The magnitude is the length, and the direction is the way it goes. A scalar is just a multiplier, and the key notation, the arrow over the top, what you see is when you have two letters in capital letters like that stuck together, that's the vector of AB. All right, that is the little arrow over the top shows you that it's a vector. Okay, and the little letters are underlined, okay, or by us in the exam questions. In the exam papers, they're just bold, but we have to put them with little underline letters like that. So this kind of means AB, the vector of AB, is equal to this little letter A. Okay, just algebra, isn't it? We're just representing the vector with a letter. Okay, the movement is a letter, and that's that. Okay, so I don't need to delete that, do I? Because that's up there. Now this is there's a tough one to write a method for, in all honesty. But I've given it a go. Now, this is kind of more just useful tips than it is a method. But you'll be asked to find vectors that get you from one point on a given shape to another. This is done using the little letters that represent the vector's movement. Use what you are given to get from one point to another. Watch out for ratios and midpoints, and then use it again if you need to. Okay? You more than likely will need to, unless it's a very simple one-mark question. Now, you can use vectors to show points lie on a straight line, or that lines are parallel to one another, and to do this, you have to prove that they're scalar multiples of one another. Alright, so one line is just sometimes bigger than the other, or they're exactly the same length. Okay, so in first question, PQR is a straight line. The ratio of P to Q to R is 3 to 1. And P to Q, the vector of P to Q is little a. Alright, so here, we could underline that there. There to there is this little letter A. All right. So we're going to work out the vector of R to Q in terms of A. So we want to go from there to there. So we want to be going that way. All right. So we just need to know what this difference here is and then reverse it. All right. And we'll get it. So what we've got is a ratio that helps us out. Right. 3 parts to 1 part. Okay. So if this is 3 parts, if A is worth 3 parts, then this is worth 1/3 of that. Okay, so Q to R, I'm going to write down Q to R, is equal to 1/3 of A. Okay, and then all we've got to do is reverse that. So actually, we've got the answer pretty quickly. All right, so R to Q is equal to minus 1/3 of A. Okay, that's really tricky, I think, to think of. You just got to get your notation right as well. Alright, so hopefully that makes sense to you. You could think of this as being A plus something, alright? That's something. That's going to be 4/3 of A. If you added those together, that's 4/3 of it. Alright, the whole lot. Alright, and then you could work it out that way, but that's just a longer way to do it. Now, question number 2, M is the midpoint of AB. Okay, so this line segment AB, M is the midpoint of it. We've got to find N to M. All right, so we've got to go from here to here. This is a very, very typical exam style vectors question. All right, we've got to go in that direction as well. All right, so the way we do this is we work out, that's supposed to be a straight line. We work out some of the things that we don't know, right? Well, we do need to know how to get from A to M. So let's work out what A to B is, right? Because we can work out what A to B is. We can go down this way and this way to get from A to B, all right? So it's thinking of the journey, but thinking that way is blocked. That way is a roadblock. We don't know how to get down that way, so we go the way that we do know. And we can see that this N to A is little a, and O to N is 5 A's, all right? So we're going reversing those, we're going backwards. So we're going A to N is minus A, and then minus 5A. So A to O, I'm going to write down A to O, gets us from here to here, right, is minus 6A, right, collecting the A's, but negative. And then we're going to go positive 4B's to get to B, all right, so O to B is equal to 4 b's. All right, now collecting these things together, we can get from A to B. All right, and A to B is, let's put the positive one first, so 4b minus 6a. Okay, now that's this whole distance from here to here. We could write that on there if we wanted to, right? But we've got it written here, right? Now, what I'm going to do is go from here to here, and m is the midpoint, right? So that's half of this. So A to m is equal to, love it, there we go, just put the little letters underneath, so I'm forgetting to do that. Right, A to m is half of this, right? So that's going to be 2b, and then minus 3a, okay? I forgot to do it over there as well. I always forget to do the little letters, little lines underneath the letters. All right, there we go, gone back and done it. So A to m is that, right? Now we can get from n to m, because we know what n to a is and then A to m is, all right? So we can go n to a is a, all right? So let's write that down, n to a equals a little a, okay? And then A to m is this, we've already got it, so we're just going to collect those together. So that's going to be n to m, and that's the one we wanted. Let's just write that down there, because that's the one we wanted. N to m equals, and see what I mean, it takes a few steps to get there. It's going to be a minus 3a plus 2b. So I'm going to write down the 2b first, and then minus 2a, and that's it. We've done it. We could, because this, you can take a factor out here, we could actually write that, and probably should write that, as 2 and then brackets b minus a. Alright, just factorised it. There you go. So, in question B, we've got to work out the ratio of n to m and to n to c. Alright, so from here to here, and then here to here. Alright, so we can get from here to here by going this way. Right, so I'm going to go n to o first of all. And we've already got n to m. Alright, and we can see what that vector is. Right, but n to o is minus 5a, and o to b, sorry, I might as well go o to c. O to c is 5b, so o to c equals 5b's. So we're going to collect these together so we can get from n to c. N to c is equal to 5b minus 5a. Right, good news is, right, we can factorise that again. Okay, so n to c is, I'll write it down just next to it like that, 5 and then b minus a. Right, so what's the ratio? Well, n to m is 2 and n to c is 5. Alright, we've got the ratio of 2 to 5. 2 dot dot 5, because that's the number that's in front of the same vector there. Okay, and this also, incidentally, for this question, means that NMC is a straight line, because this one, n to c, is a multiple, or exact multiple, of n to m. Okay, and m is that point that's in common between them. Okay, hopefully that makes sense. Alright, I can't really do much more for you on that one. Right, let's have a look at this third and final question in this particularly tough topic and tough series of questions in Pythagoras and trigonometry section. So what we've got here, A to B, so there to there is 5p. It's not labelled on there as 5p. We've got D to C is p, and that one is labelled on there. And then we've got D to A, which is, there's that and there's that. Again, that's not labelled on there, and that's 2q minus p. And then A to B is parallel to DC. Alright, so what we've got there actually is trapezium, because this line's parallel to this. M is the midpoint of AD. This is what vectors questions do, chuck loads of information at you. A to N, there to there is 2 parts out of the 5 parts. Alright, because that's 3 parts there. N to B. Show that MN, there to there, is parallel to CB. Right, so we're saying that that line there is parallel to this line there. And we've got to prove it using vectors, and we can do that using all this information we've been given. So we need to work out what this vector is, M to N. We also need to work out what C to B is. Okay, now we can get C to B easier than we can get M to N. So let's get C to B first, right? So C to B, arrow over the top, equals. We can go backwards here. All right, so we can go b to a. In fact, I'll write that down there. All right, so b to a equals minus 5p. Right, we've gone backwards along the 5p. Then we've got a to d, and d to a is 2q minus p. So d to a there. That's not the way we want to go. We want to go a to d. So we're going to reverse that, and that's going to be minus 2q plus a p. So a to d equals, let's put p first, minus 2q. And then we want to go d to c, and that's already there. So d to c is equal to p. Right, now collecting all that together gets us from b to c. Okay, I could have gone from c to b, couldn't I? That's what I've written there. Right, don't get confused. I'm going to change that, and I'm going to put that b to c. All right, because I've done a lot of questions correct so far, so I don't want to do the whole video again. But b to c, right, going from this one to this one, so we've got minus 5p, and then plus p minus 2q, so plus p minus 2q's, and then plus another p. All right, so what we've got there, b to c, minus 5p plus p plus another p minus 3p plus minus 2q. So minus 3p minus 2q, and then we want to go from c to b ideally, so we just reverse this. All right, now that's going to be 3p plus 2q. All right, now that's, I'm going to write that down on there, 3p plus 2q. Okay, so I have to rub it out. All right, now we need to get m to n. Okay, well, we know m is the midpoint of AD. That's fine. That's good. All right, so we can get this one relatively easy because we got d to a, which is 2q. So we know that m to a. Write this one down. M to a is equal to just d to a is 2q minus a p. So that's going to be 1q minus half p. So q minus half a p. All right. Then we've got to get from a to n. Now we know that a to b is 5p's. We know that this whole line is broken up into, we could break it up into 5 pieces because of the ratio. All right, we want 2 of those bits. All right, 2 of these. So this is going to be 2p, right, and that would be 3p. That's the ratio. That hopefully that makes sense to you. All right, so what we've got is m to a plus 2p there. All right, so I'm going to write down a to n equals 2p, and I'm forgetting to write all these little underliney bits because I just never write them. It's really annoying, isn't it? There you go, I've done it for all of them now. And those, in the other question. So a to n is 2p. There we go, m to a is, add them. M to n is what we want, m to n. All right, nearly there. So that's going to be q minus half p plus 2p. 2p minus that's 1.5p and 1q. So q plus 1.5p, 1.5p. Did I write the p's first? I did write the p's first. So I'm going to put p first there. 1.5p. So I was just looking at the other vector that I wrote. 1.5p plus 1q. Right, and then what we can see, if we look back at this bit here, the CB vector, and then we compare it to MN's vector, what we can see is that if we had 2 MNs, so 2 MNs is equal to 1 CB, the vector of CB. Okay, and we can write therefore parallel. And we've proved it using vectors. Alright, show that MN is parallel to CB. Done. That's it. Alright, very tricky stuff. Very, very tricky stuff. But hopefully you've followed what I've shown you there. There's plenty of these sorts of problems that you can practice. Yeah, I will make sure that you have got some good ones. Thank you so much for watching. Thank you for sticking with us on this whole tough topic section. Up next is the last section, which is the probability and statistics section, which is quite nice. Some nice stuff in there. All right, stuff that you're going to enjoy if you've enjoyed it so far. Take care of yourselves. Look after one another. Bye bye.